Hey guys, what's up everyone? Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akeen, your math instructor, and in today's video we are going to be doing a tri-weekly exam paper. We're going to be applying some of the knowledge that I would have exposed you to on this channel, as well as there's some other concepts related to videos that are coming up on this channel. So this is actually an exam paper that I had constructed. As you can see, the date is right here, which is just a few days ago. And so you would have seen here that this video is being done primarily to give my students a clear understanding on what should have been done. So for those who actually got a good grade on this exam, well done. It was a nice paper. It had some challenges, but that's how math is. So this particular video is just going to assist you in showing you what should have been done on the exam paper. All right, so for those of you who are joining the channel here for the first time, my content here is based primarily on CSEC exam topics, math related topics, and of course we do live classes. All information regarding my online tutoring services can be found in the description box below. All right, now without further ado guys, let's just jump right into the video, and we're going to be working this exam paper here. All right, so we're looking at a 2-hour paper, and the contents of this particular paper here is related to bearings application. A link will be provided in the description box below to a video that explains everything about bearing. And you would have seen here that we are actually doing some transformation, and we are actually going here to do some measurement. On the other page we would have had some circle theorems, gradient midpoint, and factorization. So this is going to be quite an interesting video guys. I want you to stay tuned with this because this video brings out a lot of concepts that's related to CXC exam structure type questions. Okay, so here we go guys, let's jump right into the video. All right, so instructions are: answer all questions related to you and show all working where possible. Calculators are allowed. And of course, the first question here states that a ship travels from Akron A on a bearing of 35 degrees to Belleville B, which is 31 kilometers away. Another ship then travels to Compton, which is 94 kilometers away, due east of Akron. With the aid of a diagram, our first task is to draw a diagram to illustrate the journey of the two ships. So we're going to go right ahead and attack that particular question. So let's hop onto a new page here, but let's just get some valuable information before moving on. It says here that a ship travels from Akron on a bearing of 35 degree. Now in a previous tutorial I would have explained to you that based on where an object is moving from. So here basically we have a ship that's moving from, say here, Akron. All right, let's just make sure that we have enough space. All right, so here we have a ship that's moving from Akron. So let's just put Akron here. And so because the ship is moving on a bearing of 35 degrees, we're going to have to establish a north line. All right. And so with that north line, then we're going to establish our 35 degrees bearing. So we're going to need a guideline. And 35 degree, obviously, right through here would have been 45. So 35 is just a little bit above the middle here, so that would have been in this direction. And we could just simply say that there is Belleville. All right, that is the distance where Belleville is located. All right, so that's Belleville. Okay, and so the bearing is measured from north in a clockwise direction. So that's 35 degree. All right. And so now we go on next to look at the fact that which is 31 kilometers away. All right, so we're going to put that 31 in a moment. Another ship travels to Compton. Right, so it's another ship, which is 94 kilometers due east of Akron. So that means both ships are leaving one location. So Akron, you see here, is repetitive. So Akron here. So another ship is due east. So let's put our 31 kilometers here. And so another ship leaves to Compton, which is due east. So due east means that the ship is traveling exactly 94 kilometers. So we're going to make this line a little longer than usual, right? Longer than this one, right? About 3 times longer. So this out here now would have been, say, Compton. All right, so then we're going to be connecting here. And so this is 94 kilometers. And they said it is due east. So therefore all of this here is 90 degree. All right. Now, as I mentioned to you that before in previous tutorial, that when you're doing bearings, you need to make sure that you find some of the smaller the angles in between. So here we already see that we could find the angle here, because then 35 away from the total angle of 90 here will give us, say here, 55 degrees. All right, 55 degrees. So this would basically answer the first part of the question that states that you should draw a diagram to indicate the journey of the two ships. And that is it. All right, 94 kilometers due east. We're going to put that on in a moment. Now it says here, show on your diagram the bearing 35 and the distance 31 and 94. So that's 5 marks just to do what we've just done there. All right, let's just move on to the next question. What is the nearest, calculate to the nearest kilometers the distance between Belleville and Compton where the two ships went. All right, so we're looking for the distance here. Could just probably indicate this with a X. So we're looking for this distance right here from Belleville to Compton. All right, we have our 94 kilometers here and all of those stuff on the diagram. All right, so we're looking for this distance between here and here. So basically now you can see that we have one distance here and we have a distance here, and we had previously calculated the angle between the two sides. So according to the cosine rule, a link will be provided in the description box below for that formula. We know that we'd have to apply the formula c squared is equal to a squared plus b squared minus 2ab multiplied by the cosine of theta. All right, so therefore then the side that we're looking for here is obviously Belleville to Compton, so that's going to be marked by the letter X. All right, and then that's going to be equal then to the two sides, which is 31 squared plus 94 squared minus 2 times 31 times 94 multiplied by the cosine of the angle between, which is 55 degrees. All right, so next then we're gonna just carry this down all the way, and we're just gonna hop onto our calculators. Pardon me, guys. And we're gonna have here, say 31 squared, that's equal to 961 plus 94 squared, that's 8,836 minus 2 times 31 times 94. That gives us 5,828. And then we're going to multiply that now by the cosine of 55. That is equal to 0.5736 rounded off, okay, to to 4 decimal places. So we're going to carry this down all the way here. We're going to therefore then say 961 plus 8,836. That's going to be 9,797. And then you see here that 5,828 multiplied by 0.5736. We get 3,342.94. Right, and then therefore that is equal to, okay, so that's 9,797 point, well, that's not point, take away 3,342.94, and that's going to be equal to 6,454.06. So therefore then we can say then that x squared, you can say then that x squared is going to be equal to this. So x, pardon me, it's going to be equal to the square root of 6,454.06. So let's go on our calculators then. 6,454.06. That would give us a value that x is equal to 80.3 kilometers. Alright, so that is the distance that is here. Okay, so that's 80.3 kilometers. Right, and that is it. That is how you actually work out the first part of that particular question. Alright, so let's have a look now at, say here, we are to calculate to the nearest degree the bearing of Akron, but we are measuring it from Belleville. We're measuring it from Belleville. So we're going to need some sort of north line here because the measurement is being taken from Belleville. Alright, let's just write Belleville over here. Let's just name Belleville. Okay, so that's Belleville. B-E-L-V-I-L. Okay, okay. Alright, so we're measuring this bearing then. So this is the bearing. The bearing is measured from north in a clockwise direction. So we're looking at coming around here, all the way around here to the line leading us to Akron. So we're looking for all of that bearing there. Okay, now once you're measuring a bearing, geometry is going to come into play. So right away I know that I can actually here construct a south line. And that south line basically is going to divide up the whole entire bearing into two sections. So we're going to be having this side here, which we know now that from north to south equals 180 degrees. And therefore, in here is all we need to find to complete the bearing. Alright, so if we can somehow calculate this piece of angle here, then we're good to go. Now that angle can easily be gotten or can be attained by using the alternate angles theorem. So that's here, you see that north line runs parallel to the constructed south line that we see here, so it forms a Z angle. So it says here that the angle 35 degree is going to be alternately equal to the angle in the bottom arc here of the Z. So this angle here that we're looking for is actually 35 degree. So therefore then the full bearing would have been the 35 degree here plus the 180. So the bearing that we're looking for, the bearing of Akron from Belleville is equal to 180 plus 35 degrees, right? And that's going to be equal to 215 degrees. If you want to give a reason, you could say that alternate angles are equal. I guess that would be the best. Alternate angles are equal. Okay, right, so that answers that particular question. Let's now have a look at another question. not another question, but the final one. We are to calculate the angle ACB. We are to calculate the angle ACB. So let's locate the position of that angle ABC. Oh, I didn't think I need Akron. Okay, let's look at that again. It says angle ACB. Okay, so ACB. So we're gonna, it says Akron, Compton. So we're looking for this angle in here. Okay, we're looking for this angle here. All right, so I guess geometry is not going to play a role here because we have this 55. We don't have the angle exactly between. We have 180 coming around here. So we need to, we cannot use the interior angle theorem, the triangle theorem, where we add up all three angles and equate it to 180. So that cannot be done. We can use the sine rule though, because remember, according to the rules of sine rule, that if you're looking for an angle, let's call this angle here theta. Let's call this angle theta. Okay, and so if you're looking for an angle, then we must be provided with the side that is facing the angle. So we have this 31 here. And then if we can find another side and its opposite angle, then we're good. So we have this 80.3 that we had calculated, and we also have the angle in front of it, which is 55. So we could therefore use the sine rule. And so the sine rule, let's just revisit it here. The sine rule here is, say here, A divided by the sine of A, and that's equal to B divided by the sine of B. So we've got to choose a side to represent our letter A. I could perhaps choose here, say 31 to be my A. So the angle, which is what I'm looking for, that is in front of small a becomes big A. And then therefore here we can name this opposite side here, which is B. And we have the angle facing it, which is going to be, say here, big B. All right, so we're good to go. We can set that up. So it's going to be 31 divided by the sine of the unknown angle. So that's going to be 31. So that's going to be 31 divided by the sine of the unknown angle, which in this case is A, or we can say that it's the angle ACB, which is equal to A. Alright, so that 31 divided by the sine of A is equal to B, which is, say here, 80.3 divided by the sine of the angle, which is going to be in front of it, which is 55 degrees. Alright, so let's go here. We have 31. This was previously a tutorial made on my channel, so you can check that out about how to use the cosine rule to solve for missing angles and sides. And that's going to be, say here, the sine of 55, which is equal to 0.819. Okay, so this is 80.3, 0.8191. All right, so if we go ahead and we say here 80.3 divided by 0.819, then we end up with 98.05, and that's equal to 31 divided by the sine of A. Now we already explained that when the unknown is at the bottom, we just swap positions. That's 31 divided by 98.05, and that's equal to sine A. So sine A is then equal here to 31 divided by 98.05, we end up with 0.316. So therefore, to find the angle, then that's going to be easy. Alright, so we're going to have here A is equal to arc sine of 0.316. So approximately 18 degrees. So the angle here representing A is 18 degrees. So therefore, this angle right here is going to be, say, 18 degrees. All right. And so in the event that they did ask us to find this angle, the complete angle between here, then we could just perhaps add, say, 55 and 18, which is 68, and take that from 180. Then we should find our answer here being equal to 112 degrees if we needed to find this piece of angle here. All right, so that pretty much ends this particular video. I thought that I could actually go ahead and work out a whole entire paper, but I'm gonna have to work the questions in parts. I'm gonna be focusing primarily on the questions that students thought was a little challenging. So hopefully this particular tutorial helps you guys, and this is yet another video related to trigonometry. So hopefully you should be able to see a question like this on your exam paper and you'll be able to master it. All right, so do take care until next time. Bye bye.